A particle of mass m is projected with a velocity v, which is equal to k times of escape velocity, where the value of k is less than 1. That means the particle is projected with a velocity less than escape velocity from the surface of Earth. The maximum height above the surface of surface reached by the particle is. So over here we can just consider that it is like Earth over here, and from the surface of Earth a particle is projected with a velocity which is equal to nothing but k times of escape velocity, so that after some times it is going to reach the maximum height. Let's say it is reach a height that is equal to h. Now in this type of question we can solve it by using law of conservation of energy. Don't try to solve it by using normal the equation of kinematics, because that is valid only when g is equal to a constant or near to the surface of Earth. So we can use that equation. Total energy at point 1 should be equal to total energy at point 2. So we are just writing it like this: total energy at point 1 should be equal to total energy at point 2. Total energy is a sum of kinetic energy plus potential energy at point 1 should be equal to kinetic energy plus potential energy at point 2. Now at point 1, where does it reach the maximum height? Its kinetic energy is 0, and potential energy, you should not write mgh, you should write minus of gmm divided by distance from the center. We know that it is r plus h. You should not write h, you should write it is r plus h, because for gravitational potential energy we need to take the distance from the center of Earth, is equal to kinetic energy when it was projected is, or at point 2, is half into m into k times of escape velocity the whole square, so half mv square, plus potential energy, it is not equal to 0. We should write the potential energy on the surface, that is gmm divided by r. Now we can put the equation for escape velocity, so we can write as minus of gmm divided by r plus h is equal to half into m into this k square into, we know the equation for escape velocity is under root of 2gm divided by r. So if you are squaring it, you will get as 2gm divided by r minus, we can take it as gmm divided by r. Now we can cancel the common terms like gmm over here and gm and m over here and gmm over here. So the remaining thing is minus of 1 divided by r plus h is equal to the term over here is k square, and you can observe that this 2 and this 2 is also get cancelled. So it is k square divided by r minus, we can take it as 1 divided by r. And Rm is to find out what about the value of h. Further we can take it as 1 divided by or minus of 1 divided by r plus h is equal to nothing but k square minus 1 divided by r. Or just to cancel this negative sign, even if you want, you can write it like this: it is minus of 1 minus k square divided by r. Now we can cancel this negative sign and this negative sign, and we can just cross multiply it. So r is equal to 1 minus k square into r plus h. So we can write it as r divided by 1 minus k square, 1 minus k square is equal to r plus h, or you can write the value of h is equal to r divided by 1 minus k square minus r. Now if you are taking this 1 minus k square as LCM and r as common, so we can take it as it is nothing but r into 1 divided by 1 minus k square minus 1 is the value of h. Or you can write r into, if you are taking this 1 minus k square as LCM, it is 1 minus k square is equal to the value of h. Or you can write this as r into 1 minus 1 plus k square divided by 1 minus k square is equal to h. So we can cancel this 1 and minus 1, so the remaining things will be equal to r into k square divided by 1 minus k square is equal to the value of h.